Okay, we're going to now talk about the second method of solving a system of two equations, which is called elimination or addition. I did forget to mention, I kind of talked about it, but I didn't read this last note on substitution. That method works the best when one of your variables has a coefficient of 1 or -1, as I was describing in the examples. That makes it so you don't have weird fractions that are just going to make the arithmetic harder. So I would generally advise that you try the elimination method if none of your x or y variables has a coefficient of 1 or -1. So what is the elimination method? This explanation here is a little bit lengthier. So let me just give you the general idea. What we're going to be doing is adding the two equations together. And when we do that, we are going to set it up so either the x or the y terms are going to cancel each other out. So what I'm actually going to do in this video is start with the first example so we can kind of walk through the example together. And then we'll go back and read the directions for how to do it. So if I'm looking at this first example here, I can see that I currently do not have, if I were to add this and this together, the x's would not cancel, nor would the y's. But if this happened to be a 7y, then when I added these two together, their coefficients would be opposite and they would cancel. So what I'm going to do is I'm going to do one of our legal moves with equations, which is I can multiply both sides of the equation by the same number, right? And that will give me a new equation equivalent to the first equation. And now I have that positive 7y there. So if I'm just going to recopy the first equation underneath it, now if I were to add these two equations together, the y terms would cancel, and I'd end up with a 23x equals -138. Divide by 23, pull out the trusty calculator for that, and I get -6. So the elimination idea is that I am eliminating one of the variables, or the addition is that I'm adding the equations together in order for them to eliminate. Now I still only have half of my solution, so I'm going to take that 6 and plug it into either one of these top equations. I think I'll choose this one since the y is pretty easy to get by itself there. So 3x plus y equals -20. And then just work on solving that for y. Add the 18 over, I'll get -2. So it looks like my solution to this system would be -6, -2. And again, I can kind of mentally just check that. -12 plus 14 is +2. -18 minus 2 is -20. So a quick mental check tells me that we did that one correctly. So now let's go back to the previous page and just walk through the instructions here. So one of the things that you'll notice as you move along in math is that it becomes harder and harder to mimic things. If you're just saying, oh, it looks like this, I'm just going to copy that process over here to this problem, that only gets you by for so long. And a lot of people do get through their math classes that way. But particularly once you get to calculus, it becomes impossible to do, and you really have to make sense of and understand the procedures that you're being asked to do. You have to understand why they work and what's going on. And one of the best ways to do that is to explain things with words, not just follow the procedure and apply it to your problem, which is why I have you go through notes and not just dive right into the homework. So I always have these sets of how-tos with various steps because they're really helpful for you to be able to understand and explain what it is you're doing while you're doing it. So what did we just do? When you go to solve a system by elimination, the first couple of lines are for setup. So you need both of the equations to have x and y together on the left side, constants on the right. That's just for the setting up when you add them together. And then you're going to write one equation above the other, lining up the variables. Now, if one of the variables in the top equation has the opposite coefficient as the same variable in the bottom, go ahead and eliminate. add them together and eliminate. If not, then you're going to use multiplication. Obviously, you can't multiply everything by 0. That won't really help you. So that one of the variables has in the top has the opposite coefficient as the variable in the bottom. Then you add together and eliminate. And I will mention here that you might need to multiply both equations by a number or different numbers for each equation so that they will line up and be opposites. Or you may only have to multiply one, as we did in our first example. So you will have solved for one variable at the end of step 2, put that into, at the end of step 3, put that into one of the original equations and get the second value for step 4. And then always a good idea to check. So here we are back at some examples, and we're going to try the same process. And you're looking at this problem going, oh my God, the fractions, I don't want to. But here's a great thing about fractions in equations. We can use the same technique we used in the first one to get rid of these fractions by multiplying both sides by the same number. What number could I multiply the left and the right side of this equation by so that all of the denominators would cancel? I need to cancel a 3 and a 9. So it seems to me, to make that a little bigger, that if I multiply both sides by 9, that will get the denominators to cancel. 9 times 1/3, 9 divided by 3 is 3x. 9 times 1/9 is just 1, y. And the 9s cancel on the right as well to leave you with just 2. So this multiplication step is a great way to get rid of the fractions in an equation. Similarly, on the second equation, I have a 2, a 5, and a 3. What could I multiply by that will cancel 2 and 5 and 3? Let's see, I can't use 10. I can't use 15, but I think I could use 30. So let's see what that gives me. 30 times -1/2, it's basically 30 divided by -2. So that would be -15. 30 times 4/5, so the 30 would be divided by 5. That gives me 6. 6 times 4, that's 24. And last but not least, on the right side, 30 divided by 3 is -10, or is 10 divided times -1 is -10. So great reason why we had to be able to deal with fractions before we even started this class, or before we started the actual lessons of the class, is because they don't ever go away. So now I'm kind of done with the fractions, and I'm left with this system of equations. And I want you to now pause the video and attempt to solve this system of equations using elimination, not substitution. Try elimination, and then unpause to check your work. How did it go? So what I chose to do, seeing that this was already a -15x, I multiplied the top equation by 5 on both sides so that this x coefficient would line up as a +15 and those would cancel. It's not your only option. You could have multiplied this by -24 and canceled the y's instead. You should end up with the same answer. So doing that, I got this as my new first equation, added it to the second equation. The x is canceled. I solve for y. 29y = 0 means y is 0. Divide 0 by 29, you still have 0. And then I plug that 0 into the first equation. That eliminates this term. I have 1/3 x = 2/9. And then to get the x all by itself, I multiply both sides by 3. So I end up with 2/3 for x. Keep in mind, when you write it as an ordered pair, the x always has to come first. So even though I found y first, y is the second coordinate and x is the first coordinate. Okay, so we have 2 more examples here. And I said solve them using any method. Okay. And so again, I'm going to have you pause the video for a moment and work on solving them by any method you like. If I'm peeking at this, I see that this one is already ready for substitution. This one I could probably do either way. I could either move the 3y over and substitute, or I could just multiply the top here by a -3 and eliminate. So start those problems off, give them a try, and then come back after you're done and check on your results. Okay, welcome back. Did you get some weird things? Yeah. So I followed through on my substitution method in this first example. I substituted in the 9 minus 2y for the x, but then the plus 2y and the minus 2y cancel each other out, and I'm left with 9 on the left side and 13 on the right. So what's happened is I've ended up with an equation where all of the variables canceled, and I'm left with a numerical statement. The numerical statement in this case is false. It is not true that 9 equals 13. So what does that mean? What could that possibly mean? Remember the 3 scenarios we had for a system? We've been solving all the ones that were consistent, right? They had one ordered pair solution. My 2 lines were intersecting in one place. What do you think is happening in this system? If it's false, it's never true. That means that there is no solution to this system. And graphically, what that means is these are parallel lines. See? So knowing what the options are is helping you understand what's actually happening when you solve it algebraically. Let's come over to the second system. I followed through my elimination. You could have done it a different way. But when I eliminated, everything canceled on the left. So I end up with 0, and everything canceled on the right. I guess I could have done that. And so I have 0 over there as well. And my new equation is 0 equals 0. So notice that is a numerical statement as well, but this time it's true. It is true that 0 equals 0. So what could be the solution to this system? Which one of the scenarios is it? This is the one where they are the same line. So there are infinite solutions. Basically, every point on the line is a solution. And graphically, this means that this is a system with 2 equations of the same line. So when you are solving 2 by 2 systems or 2 equation, 2 unknown systems, it is possible that you're going to get all the variables to cancel. And then you have to determine if it's no solution or infinite solutions based on whether the thing that you are left with is either false or true.